ball up here than down here where the golf ball is actually moving in the same direction as the air. And so what you find is that this carries the air around a little bit below and behind the golf ball. And so this ends up giving you a deflected flow, and now you just go ahead and use Newton's laws. Newton's law says that for every action, this is now Newton's third law, for every action there's an equal and opposite reaction. So if the rotation of the ball pushes the air down, the air must be pushing the ball up. And so in fact that's what happens. The rotation of the ball pushes the air down, you get a lift force from that air you're pushing down that actually makes the ball fly up as it spins. And so that's good. The energy that you thought you were wasting by giving spin with your club hit actually helps your ball fly up higher in the air. And so if you now put all these together, you get something like the right range plot that if you were to just imagine my initial calculation without any drag and any lift, you would see this beautiful parabola. It would go too far. If you add the drag, it doesn't go quite far enough, but the flight of the ball, this aerodynamic lift effect, actually means the ball moves up more than the initial direction of its motion. And then when it peaks, it falls down rather rapidly. So Tom, you wanted to say something about the range of the ball at this point?
Yeah, as the TrackMan device measures all of these technical numbers and tries to simplify them for you, optimally with a driver, you don't want the ball to get much above 75 or 80 feet, depending upon your club head speed. But are you familiar with Dustin Johnson or Jason Day on the men's tour? They generate club head speeds of over 120 miles an hour. So how much ball speed would that be using one of Dr. Larry's physics laws? It would be at least. There you go. Exactly. It would be twice that number in ball velocity off of the club head. So good. We're learning tonight. As you go through, how many of you hit the ball too high, especially with your driver? So your initial thought would be, well, geez, I need less loft. Probably not the case. It's probably the angle that the club is entering the golf ball, which is sitting on that tee. You're hitting it at a descending angle instead of an ascending angle. And we can get more into that when we go next door in a few minutes. But does that help things along?
Thank you very much. That's great. Because I'm going to talk about the physics, but actually connecting this, if I could connect the physics to improving my own golf game, I would play a lot better than I do. So I'm hoping that between the two of us, we can actually make that connection stick a little bit better. And I see my friend Eddie laughing there in the audience, but that's okay. He's played golf with me too many times. All right, so you can also use this instead of giving lift. If you want to, you can curve the ball. And if you curve the ball, you basically give the spin not up and down in the direction of motion, but sideways, a side spin. And that will actually make the ball curve as well. Which brings me to possibly my favorite topic here is what actually happens when I hit the golf ball. And so you can look at the various ways you can mishit the golf ball. And I found this actually very surprising when you look into the science of mishitting a golf ball. You would think, for example, that if you hit the golf ball with the club face angled away from the direction to the target, right? So here's the idea. You're trying to hit a target up here, but the club face is sort of moving off to the side. And you think, well, the problem is that the club face is pointing the wrong way, and it gives it a knock in the wrong direction. It turns out that that effect is minor. The much more significant effect is that this angled club face gives it a sideways spin. And that spin carries the ball off more than the actual misdirected hit. And the way you can tell that is if you have a really bad sideways draw on your golf ball, that you'll find that it doesn't just move off in a line to the side, it actually starts moving and accelerating off to the side. Why is it accelerating off to the side? Because there's a force, and from Newton's law, force is mass times acceleration.
One thing to remember there, and to simplify that, and this is one thing we talk about with our players, is understanding in the heat of the moment what causes offline shots. Obviously they're out there competing, they're trying to shoot low scores. Well, what happens when they hit a couple offline? They have to know the fix for it. So when we talk about how to fix that, our players have to know what causes a draw, what causes a fade, what causes a straight shot. And the thing to remember is, if all things are equal and you're hitting the ball in the center of the club face, the direction the ball starts is caused by the open or closing of the club face. So if the ball starts to the left and you hit it in the center of the face, you know the club face was shut. Okay? Now if the ball is curving to the left or to the right, that's caused by the club path. Okay, so the combination of those two things are what cause the ball to start offline and then curve offline either way. So those are called the ball flight laws. So those are very important to remember if you're trying to fix yourself on the course.
Yeah, I'll just add to that. Our roles as coaches is sometimes to teach technique, but more it's to increase the golf IQ through the TrackMan numbers. And when you get a young man like Eric Fium, who's a mechanical engineering major, you better be on your toes with those numbers because he wants to know to the degree of the error, not or almost to the 10th degree. Yeah, that's a good explanation. There are 9 ball flight laws, and what TrackMan and devices like it have taught us is things that we used to look to solve our problem, like what direction the divot is pointed, is totally irrelevant to what is actually happening when the club hits the golf ball. So a divot means nothing anymore, or very little. The direction that the club is pointed at impact is only going to tell you where the ball starts. The direction that the club is traveling, the path, is going to tell us how much it curves in either left direction or right direction. So hopefully that gives you a little more information.
Great, thanks very much, guys. There's other ways you can mishit the ball. For example, you could actually hit it in the right direction. The club head is pointing in the wrong direction, or you can hit it off center. And if you hit it off center, it turns out that's I'll get to that in a second. So just to show that curvature effect, if you've got a slice, it's not that it's moving off in the wrong direction, it's actually curving off. There's a force that's making the ball accelerate in the wrong direction. It gets worse and worse the further that ball goes. And here's a chart in case you actually want to figure out just what angle you're mishitting it at based on how the ball shifts. Although I think, again, these radar control things probably give you a better idea of what's really going on. The one place where technology of golf clubs can help you a little bit is if you hit it off center. So it turns out if you hit it off center, that actually makes the club bend a little bit off. And as the club bends off, it rotates the other way, which is called sort of the gear effect. And so that tends to make the ball spin the wrong way. It would actually make the ball curve off. And you can counteract that by curving the face of the club in just such a way that it counteracts with the club angle the effect of this gear head. And so a modern club will both be curved to allow you a bigger sweet spot. So if you're not quite dead center, it won't be quite as bad as it looks.
So what Larry's trying to tell you is you can buy a better game.
That's true.
And the secondary effect is modern clubs are hollow and all their mass is around the outside of the club. And I think they even have a cross-section, a blowout of a golf club, the Callaway guy outside, and you can sort of see how all that mass is no longer in the middle of the club like an old wooden club. And what that does is, for our mechanical engineers and stuff, that means the moment of inertia of that club head is bigger when all the mass is distributed around the outside. So that means when you do hit it off center, it's less likely to rotate because it's got more moment of inertia. And so again, a modern club will be much more forgiving if you hit it off center than an old club.
Yeah, how many of you in the audience have clubs that are more than 10 years old? Get to your local, go see Paul right after this. I promise it'll help you.
And so, and so I guess the point is that a modern club is more forgiving. The question that's a little subtler is, if you happen to hit it perfectly, will it fly as far with a new club, with an old club, as with a new club? And that's less obvious. I think maybe Tom has some input on that. I think the only thing that was obvious to me is that the actual the club's rod itself is a little bit lighter sometimes.
Well, yeah, the design of clubs built 40, 50, and even 20 years ago, and to the clubs and the technology that's involved in Callaway. Paul was telling us earlier that Callaway has over 100 engineers in their research and development area, and they spend, is it $20 million a year researching both equipment and also an underrated thing is the golf ball has improved dramatically in the last 10 years. So the combination of a lighter club that's more aerodynamic in its design, that can be swung faster and can hit a golf ball that is built for a person's club head speed, is going to go consistently farther than anything built 20, 30, and 40 years ago. Larry, you were telling me you got your equipment's 19.
Well, I was actually my current equipment is only about maybe 10 years old.
Okay.
But I think we had some people brought some old golf clubs in. I don't know where they are right now. We can take a look at them afterwards. All right.
Yeah.
So then let's go ahead and put this all together. These missids, of course, can be used to advantage. So, for example, here's a shot from Bubba Watts.
Yeah. This is what he does. That's an actual carve with a driver. There's 40, 50 yards, a slice on that ball to get it to track into the right spot. And everybody loves it. Why not?
An amazing second shot for Bubba at 18.
He's very much hope for the best, isn't he? Maybe plan for the worst.
I think that should come with a "don't try this at home" warning. But that's a pretty amazing ability to actually use that spin effect to your advantage. And it also shows just how much of an effect spin can be. So these golf balls are not just moving through the air, they're sort of flying through the air like airplanes. And I guess you could go back and you could ask the question is, well, why do those fountains at the Crystal Gardens give these nice parabolas when golf balls fly like airplanes? And the answer is the total velocity. A golf ball's moving 150 miles an hour. Now it's interesting, 150 miles an hour, I don't know, are there any skydivers out there? No? So it turns out 150 miles an hour is exactly the speed you achieve when you jump out of an airplane. That's as fast as you go. You keep falling until you reach about 150 miles an hour, and then the force of air on your body exactly cancels out the force of gravity. And so that's, if you're a skydiver, when you reach that point when you feel there's a cushion of air supporting you. And so it's simply at high speeds that a golf ball travels at, air feels more like a mattress than like it feels like when we're just moving through it at normal speeds. All right, so then finally, I didn't say anything about putting, but we have one last video that talks a little bit about that side of the game. And so this is another physics professor, Jared Adelman.
As it travels on a green after being hit by a putter, friction tries to slow down a golf ball. The length of the grass on the green changes the size of the frictional force on the ball. As the grass gets longer, more of it stays in contact with the ball, resulting in more friction and a slower green. The smoother the surface on which the ball travels, the faster the green. They also need to account for the fact that as a ball travels faster, it will break less. On the other hand, a slowly moving ball will break more sharply. Golfers need to know whether a green is fast or or slowed in order to know how much force to apply to the ball to get it to travel a certain distance to the cup.
So that's, one could go on longer, but I think maybe I will give you guys a chance to put this stuff into action. And so here we have a screen. Maybe Tom, I'll let you talk about this in detail if you want to, but this is basically what they have set up next door. You can actually hit the ball and see all these different parameters that we talked about, the club head speed, the ball speed, the spin, and I'll let you go ahead and...
Yeah, some of the things that we were discussing earlier, the angle of attack, the path or direction that the club is traveling as it hits the golf ball. The face angle was the face open or closed at impact, and then the ratio of face to path. And then the club head speed was, that's how much energy your club brought to impact that collision, and that's how fast it came off. And what I mentioned in the first jump was the smash factor, and the higher the smash factor, the greater this differential, the more transfer of energy from the club head to the ball as it goes flying into the air. That's a good number. Hopefully you can generate that next door here in a few minutes. And then your launch angle, your spin rates, and then how far the ball carried. All that stuff is captured to, Paul, is it within 300 yards to within an inch of accuracy? So what you do indoors, you'll be doing outdoors. That's how accurate the TrackMan device is. So open it up for questions.
Great. Yeah, let me just put the last slide on, which is some thanks. I'd like to also give credit to this wonderful book by John Wesson on the science of golf. And hopefully between me and Tom, we've taught the physicists some golf and the golfers some physics. But if you still have questions, this is the time to go ahead. So thank you very much. Do you want to give them a mic?
I'll be walking around the room with a microphone, and if you guys could use these that are standing up here. And maybe you want to come over a little bit now that you're not worried about blocking that, because we can't see you. There's a light problem up here. And I think everybody wants to see you, so bring your stools a little closer. Anyway, so I'll be walking around the room and giving you an opportunity to ask questions here.
Thank you very much. That was actually quite interesting, and a humble 16.8 handicapper can take a lot away from it. I wanted to go back to coefficient of restitution, because this was a huge issue maybe 5-ish years ago. Actually, it was a split between the PGA and the Royal and Ancient, the two golf governing bodies. The PGA felt very strongly needed to be under control. The Royal and Ancient kind of said, what are you getting so excited about? And I take it from your talk it's not nearly as important as other factors of the golf swing, but I would hoping you could clarify it.
Well, I'll say a little bit about the science of it, and then maybe I'll let Tom talk about the effect on golf. So, if I can go back to that slide. Actually, really, this is probably the best. So if you want to measure your own coefficient of restitution, and I saw one of our golf team students doing this thing that I guess only golf team students do, which is bouncing the golf ball on the club without it falling off. But if you want to measure that coefficient of restitution yourself, it's actually pretty easy. You just, in principle, drop the golf ball on the club and see how high it rises after it bounces up. And that tells you what fraction of the energy is lost in that collision. But as to how that affects that in the rules of golf, I'm going to let Tom.
I think what you're referring to is the governing bodies, the USGA in the United States and the RNA in Europe, were getting concerned that the golf ball, the improvements to the golf ball and the improvements to the driver over the last 15 years were making a lot of the golf courses that have been designed obsolete, because the golf ball was going too far. So that was an attempt by the USGA to say, hey, we need to control that coefficient of restitution to a point where we can't allow the golf ball to travel as far hit with these new drivers. And so they established that standard, which Paul can talk more to it as how to the manufacturing companies are getting around those CORs, but they've dialed back that over the last 5 years, and it seems to have gone away since then. They feared that golf courses like Marion and even Chicago Golf Club here or Butler, as the golf ball was traveling too far, the intent of the designer was being distorted because the golf course was designed on a par 4 for a 4 or 5 iron to be hit into the green, and as the CORs were getting faster and faster, they were hitting 8 irons, 9 irons, and wedges, and so that was an attempt to bring that back into some balance.
When it comes to picking a golf ball, there's different factors that they talk about with more spin or distance. I'm a 18 handicap, so what should I be looking for to help my game?
One thing I'll say about the golf ball is I would first start with, do you like it around the greens? I mean, obviously we're talking about drivers and hitting the ball a long way, but you've got to be comfortable with it around the greens, that it spins enough for you and you like the feel of it. I mean, obviously you don't want a ton of spin to generate a ton of spin with your driver and your long clubs, but by and large, balls nowadays feel pretty good around the greens, but they also go a long way. But I would first start with how it feels around the greens. Do you like the way it feels with your putter, wedges, that type of thing? Is it consistent? Are the distances that you're hitting it consistent? You can get your 8 iron, hit 150 consistently, or whatever yardage it is. And then durability is also another one. You don't want to be hitting a full wedge from 100 yards and then have to get a new ball because it's scuffed up. But I would first start around the green, and then off the tee, if it's performing well enough for you, and you think you're at least getting good enough distance, then I'd go with that. But start around the greens.
Yeah. Are you looking for more distance out of your golf ball?
More control.
More control. Okay. Yeah, and then Andrew's spot on. And if you want control, if you want distance, Paul does, and all the manufacturing companies with their sales reps do club fittings and ball fittings to match your club head speed to the right ball that performs best for you. And so they can even do those indoors at the PGA Superstores and stuff. So if you haven't done one of those yet, I would suggest it.
So I don't have a handicap and I don't know very much about physics, but I'm wondering how does your hip movement and your shifting of weight factor into all the things that you've been saying?
Well, I'll come back to my picture of the swing, and I'll just say a little bit about the physics, and then I think probably there's more of the technique in that question than the physics. But from the physics point of view, you want to exert force, as much force as possible, for as long as possible. So to the extent that you can control the direction of the club, the longer your swing and the more uniform your force pull, the more velocity that club's going to have when it hits the ball. Now, how you actually do that, the mechanics of the body, I'll let.
Having not seen your swing and exactly how your hips move, the most efficient way to swing a golf club in terms of how your hips move as the club is moving is rotationally. They turn much more than they tilt or shift. So, and actually, Doc, you can answer a question for me. Rotational force, stronger, more powerful than linear force?
Well, I think in terms of rotational versus linear forces, the forces are equal, but the body's designed to rotate rather than to move in a linear fashion.
Perfect
The body's
answer.
full of joints which rotate.
Exactly. So if your hips are sliding when they should be turning, that's inefficient. So if you can get your hips turning more, you're going to generate more rotational force, speed, and your contact should improve as a result. The details of that, go see your local pro, or this guy gives some good lessons as well.
I think Eric Fione, one of our men's golfers, has something to add here.
Let's get a student athlete perspective.
Student athlete perspective here.
I mean, just what I wanted to say on that point is what you're trying to do is get the maximum velocity, and to do so, you can picture. Actually, no, this is good. So you can picture your body as like one system, and then what the ball flight and the shot you're going to do really depends on what's happening when you hit the golf ball. So it's going to be the impact that will determine your shot. But to determine the impact, that's what the golf swing is all about. And to do so, to get the maximum speed, like the rotation will give much greater energy because you're using their bigger muscles. And like, whereas if you were to swing just with your arms, you know, it would be more linear, but you wouldn't have all the leg power and hips and like back muscles. So that, you know.
So he's saying use your body more.
Back here, I have a question. Oops, sorry. So it's fascinating to me that we're talking about the physics of it, and those of us that play golf, a lot of golf like I do, 20 handicap, about 50% of the game is around the greens. So one of the things that I really wanted to learn today is how do you calculate the stimp meter? You kind of touched on it a little bit with the putting. And secondly, how much time should we spend on our short game?
Well, stimp meter is a measurement of speed of the green, and so using the physics laws, the less friction, the higher the stimp reading, the more friction or more grass, the lower the stimp reading. I think it's really important as an avid golfer, the first thing you should do when you get to a golf course is don't head to the driving range, head to the putting green and determine if you're playing a friendly game with your buddies for a couple quarters and you win more quarters than you lose, it would behoove you to get onto the putting green and to determine whether at least there's more or less friction than normal. And factors that weigh into that are, did it rain the night before? Did they cut the greens? Did they roll the greens? All those things affect the stimp reading of the green. And your job, because you're going to putt more than you do anything else on the golf course, is to dial in your feel of your stroke to the stimp of that green. And you don't necessarily even have to putt to holes to do that. You can putt from fringe to fringe, uphill to downhill, to really learn and gauge how fast that ball is moving or how slowly it's moving. And your eyes will see it, your walk and feel of the surface of the ground. Like I said, if it's raining, you're going to feel that squish. There's more friction, right? So you're going to compute that into your brain and into your hands, and you're going to be able to make very good strokes and make more putts and win more quarters.
So I'll just add one little bit of physics, which I think is obvious if you play golf, but I think it's also nice to connect with the physics, which is that if you've got a green that's not flat, then the force of gravity is going to be accelerating the ball. And so the acceleration, if you go again to your freshman physics book, the acceleration times the time squared tells you how far the ball is carried by gravity. So that the slower the ball's moving, the more the effect of that slope is going to be on the path of the ball. And so when you're calculating how to putt, you should realize that slope near the hole is going to affect your putt a lot more than the slope near where you're standing.
What percentage of time on the range?
I'm sorry, I didn't hear the question.
What percentage of time on the range towards the short game?
Oh, okay. Practice question, I'll give you time.
if you have an hour before you play, about 40 minutes should be on or around the greens, chipping, pitching, putting. If the facility has a bunker, hit a couple of those shots, because they build golf courses with bunkers around the greens, so you're probably going to get in one or two, hopefully not much more than that. And then just right before you play, just use the range to not practice, but to just loosen up your muscles and get ready for that round of golf. And then if you're practicing, if you're going to a facility just to practice and you have a couple of hours, you can split that time evenly, an hour of full swing and an hour of short game. But if you're going to play, practice what you're going to be doing more of on the golf course. Shots around the greens and putting.
Why mess around with that backswing stuff? Why not just hit the ball like you're using a baseball bat?
I'm sorry, could you repeat that question? I didn't quite hear it.
Why mess around with the backswing stuff? Why not just hit a golf ball like you're using a baseball bat?
Well, I think that one is again, if you look at the diagram, if you look at this diagram here, I mean, you want to, of course, the swing of a baseball bat is not that different than the swing of a golf club, but the force, probably the next slide is better, the energy you give to that golf club is the force times the distance, right? So the longer you have your swing, the more energy you put into that golf club, the more energy goes into the ball, the more velocity you have. So you want to do everything you can, provided you can control the direction, to put as much energy into that swing as possible.
Who asked that question? Paul, give him a sleeve of golf balls. That's a really interesting question. All the devices that test equipment, Ping, Titleist, I'm not sure what Callaway uses, but none of them have backswings. They're all loaded. They put a ball in and there's only forward motion. Now that's a machine versus man. My belief, and I've had some, in my previous days as a PGA golf professional back in Ohio, there were guys that experimented with no backswings, literally setting the club and moving forward. The problem is they can't generate enough speed and force to hit the golf ball that far yet. The accuracy is there, so as evolution takes place over the next 50 years, I think you're going to see someone try to play professional golf that way. That's just me. I'm thinking like you.
So I have a question about over here. You kind of talked about the length of the club as you're coming down in the swing as far as the physics principle. So this is kind of a question for both of you. Does the length of the club really change how much force you're able to generate? And then also there's been some advertisements about different set lengths for your iron sets, as like adjusted lengths for each club or having the same length. So wondering kind of the physics principle of that is as far as the length of the club, and then what does the difference in the two different types of sets have on your relationship to your swing?
So I'll start with a little bit of the physics, then I'll hand it over to Tom for the golf stuff. If you look here, whoops, where was it? I had one picture of it. Yeah. So if you look here, you can actually see that as you swing that golf club, the club is really bending quite a bit, right? So you've got, in the parlance of physics, you've got a mass and a spring. And if you've studied physics at all, you know that when you have a mass and a spring, you get oscillations with a particular frequency. And so that gives a natural frequency to how fast that club head vibrates back and forth. Now you don't want that frequency to be arbitrary. You want the club head to be going backwards when you swing here and to just come around and be forwards a little bit when it hits the ball. So there's an actual time constant associated with that club mass spring system, which you want tuned properly to your swing so that it's at the right point in its cycle when it hits the ball. So that's the physics of it. I'll let these guys talk about that.
Have you guys ever watched like the World Long Drive Championships? Most of their drivers, what are they, 48 inches? 48 to 52 inches. Normal drivers are 44 and a half to 46 nowadays, so clearly there's got to be some physics with length of driver, because the guys who are making a living and trying to hit the ball as far as they can are playing with drivers that are 6 inches longer than you and I are. Now, to the contrary, when we play, in tournament golf or just for fun, and you start spraying the ball off the tee, what is one adjustment that you could theoretically make to give yourself a better chance to hit the ball straighter? You choke up on it. Whether it's a half inch, an inch, whatever it is, that gives you at least a chance to control the ball a little bit better. Control your swing, maybe you swing a little shorter. All those types of things are in an effort to hit the ball a little straighter. That's more of a control thing. So obviously, shorter the club, easier to hit straighter. That's why you hit your wedges farther than you hit your driver. It's kind of basic stuff there. Now, Bryce, if you guys are familiar with Bryson DeChambeau on the PGA Tour, all of his irons and wedges are the same length. They're 6-iron length. So from his, I think it's like his pitching wedge through his 3-iron, they're all the same length. Now for him, he does that because he just likes to keep his posture and everything the same throughout the bag. He doesn't have to worry about different angles, different posture for different clubs. He has one posture, he has one speed of swing, he keeps it the same throughout. Now, I've never tried that sort of thing. I've held like a pitching wedge that's a 6-iron length. It's pretty unusual. But by and large, shorter clubs go straighter, longer ones you have the ability to hit the ball further. But that's my feeling on all that.
And if you have you ever, we have a great outfit based in Chicago here called Club Champion. They're a terrific club fitting company. They have locations all over Chicagoland. If you've never been fit and you're wondering what is the optimal length for me to hit a 6-iron, should I be shorter, longer, that would be a good road down to go. Give them a call, get a fitting, and the great thing about club fitting there is you get to experiment, and they're going to tell you which one works best. There's no answer until you find one. I hope that answers your question.
All the way in the back. Coach, I'm guessing this is for both of y'all, so if you want to keep the mic. You probably grew up playing when I did, learning that the direction the golf ball started was a function of the path on which you swung it. And so when the TrackMan and launch monitors became popular, I'm guessing that kind of blew your mind like it did mine, and said, all right, well, I guess it's the face angle relative to the path. How did that change, A, your thinking about how to strike the golf ball, and B, your thinking about your teaching technique? Because that really kind of shattered what we all knew and assumed was the 9 ball flight laws.
That's a great point. It knocked me on my rear end when I started learning all of the what radar technology brought to instruction, and it's literally changed the game. And what I think it did for me was it made me rethink everything and look to what it did for me as an instructor is I started to look more and more at how the body influences the direction of the club, and less at wrist angles and swing plane and those things. And especially in my world, I deal most of the time with 18 to 22-year-old young male and females who are in great shape. Their bodies don't have 3 knee surgeries and things that slow you down or prevent you from using your body the way you want. So I found that by teaching good biomechanics in how to use their body, they have great feel and hand-eye coordination. They make that club swing in the right direction. All you kind of have to do is get them in good angles at address, slow them down more than speed them up, and use the TrackMan to help teach them how to teach themselves. So I hope that helps.
Coach, in reference to the gentleman here in front of me that asked about hitting a baseball in comparison to hitting a golf ball, I think I can answer that relatively easy. In golf, obviously, we're hitting an object standing still. And we have to apply all the power to it, hence the backswing, the hip movement. In baseball, you're already in the backswing.
Well
And
said.
then you already are, you're back here. And the ball's coming at you anywhere between, depending on your age and level, anywhere between 70 and 110 miles an hour. So it is supplying the majority of your power. So that is your backswing when you're in their stance. You obviously have a follow through with your hips and rotation and everything else. But in my opinion, that's a simple way of the difference between golf and baseball. You're applying all the power in golf. The ball is supplying the majority of the power in baseball.
Yeah, very well said.
Okay, we have one final comment over here, and then we're going to have our drawing, and we're going to go next door.
Oh, I actually had a question about why the correction from the manufacturer is about the 2 degree upright or 2 degree flat.
Oh, that's referring to the line angle of the shaft, and depending upon how you're, want to grab that iron, and depending upon what type of swing you have and how your club head comes crashing into the ground, would cause you to want to be adjusted either flat or more upright. That's really relative to the plane that you swing the club on, and that's more of a club fitting combination instruction. If you're taking really deep divots, don't adjust your clubs. Take some lessons and get your swing plane shallower so you can do less damage to the ground and your hands and hit the golf ball a little bit more with more force, because when it hits the ground as it's hitting the ball, it's slowing down too much, right? We don't need for that to happen. So it's really a lie angle issue.
Great. Thank you for the wonderful evening. It was very insightful.
Thank you.
Don't go away because we're going to have a drawing, but I think Brad has something to say here.
Well, first off, I'd like to thank Dr. Lurio, Tom Porton, and Andrew Frame. Just an outstanding job, a terrific presentation. I also want to acknowledge our women's golf coach, Kim Kester, is here as well. So, and just to, we talked about the outstanding student athletes that we have here at NIU, particularly on the golf team. I want to acknowledge our women's golf team and Kim. Just a couple of weeks ago, they finished in second place in the Mid-American Conference Tournament. That's the best ever placing for NIU women's golf. So, obviously, and then finished their Mid-American Conference Tournament last weekend in fifth place. As you know, we're hosting the NCAA Championships at Rich Harvest Farms in nearby Sugar Grove. That's the home of the Huskies. So the tournament's going to be nationally televised on the Golf Channel, and in fact tomorrow they will do the pairing show live on the Golf Channel at 11 a.m. Central Time, where we will find out the teams that will be competing in the regional championships for the men's championship. I was a little late in getting here because I was at Wrigley Field meeting with the Cubs. They're going to be doing live shots with some of the participants we anticipate that will be in the championship. Some of the coaches of the teams will be doing a live shot from Wrigley Field tomorrow. And you will see, we're hoping that you'll see, we're going to have the defending champions from women's golf, the University of Washington Huskies. Their mascot, Harry the Husky, is going to be there. The Oregon Duck, we all are familiar with the Oregon Duck. They won the men's championship last year. The Oregon Duck's going to be there. And of course, who else? Victory Husky is going to be there as well. So tune in from 11 to noon for that pairing show. You're going to see some familiar faces. You're going to see, I think, perhaps Coach Mike Small, who's the head coach of Illinois. The University of Illinois is one of the top golf teams in the country, and we're anticipating that they will advance into that championship round. But I think in just a few years, you're going to see Coach Borton's men's team and Coach Kester's women's team there at the championships someday as well. And so thanks again for coming out. I want to give yourself a round of applause. The questions and the interaction was absolutely fantastic. Thank you so much. Thanks to our good friends at Two Brothers as well. I mean, great partners here. And now let's get to the drawing and get to the demonstration in the room next door.
First of all, I need to know if anybody didn't get a red ticket.